Hello everyone, welcome to Pepcoding. So in this video we are going to discuss a question. The question is named as binary tree coloring game. So here we are actually playing a game with our opponent. So what is this game? The rules are defined here in this column, but I'll give you the brief introduction, like what is the actually game, what the actually game is, and how we are going to determine that if a player is winning or losing. So game is like this. uh, our opponent first will color, let's say he uses a red color and he will color any random node that will be given to us, that which node he is going to color. So our opponent is going to color any random node in this binary tree. Now this binary tree going to have number of nodes as odd number of nodes. Here you can see total number of nodes are 11. So there will be a person who will be winner. So what is the game? First I'll tell you what is the game. So he will color the opponent will color any random node. Now we have to color, the second turn is ours, so we have to color, we can also color any random node. Now we have to determine, for let's say we colored this too. Now we have to determine that we have, in the end we have to determine that the number of nodes colored by the opponent and colored by us, which among those which is greatest, and the player who is going to have the maximum number of nodes colored is going to win. So in the end we have to return true or false, that is if we are going to win this game or not. So to win this game, obviously we have to color nodes more than this opponent's node. For example, we are going to get equal number of chances, but as the number of nodes is odd, therefore there will be a person that is going to color one more extra, that is one extra than the other player. For this, for example, at this place, let's say three colors this, we color two, then let's say three colors this 10. At the same point we color this 1, again three colors, let's say 7, we color this 4, three colors 6, we color 5, now three colors 11, and we make a color to this 8. Now 3 has the last chance, and 3 colors this 9. So here you can say that 3 has colored how many nodes? 1 2 3 4 5 6. And how many nodes are colored by us? The number of nodes colored by us, 1 2 3 4 5. So you can see here we are the loser here, right? Now this is an important thing, that we colored all the nodes. Now let's say I'll first write that x is going to be given to us. Let's say for here x is 3. X is the starting point, or the starting node where the opponent is going to color. Now to see if we are going to win or lose this game, what we can do? The approach is simple. That first we have seen that if we randomly color any node, that is not going to make us the winner, as we have seen in this example only, that we have randomly colored all these nodes and 3 colored these nodes, therefore 3 was the winner. So what we have to do, what we can do, I'll just go back and write this here. N is given is equals to 11, that is always going to be odd number of nodes. X is going to be, let's say, 3. Now what we can do, actually we have to look for a way to increase the result of blue to increase, and we have to look a way, or look a path, or look a certain method through which we can decrease the result of red. We have to look for a certain way through which we can decrease the result of red. So if this is clear, that we have to do both of these things, obviously. Now what we are going to do, let's say 3 has opponent has colored this 3. Now how we can actually decrease the result of red and increase the result of blue. Actually I forgot to tell you one thing. There was one more constant. This constant is really important, because this is how we are going to this is the main important point that we are going to use to win this game. Actually the thing was given that if you color any node, let's say if opponent has colored this node, then the possible nodes that opponent can color are its neighbors only. That means its connected nodes. For example, if if opponent colored this 3, he can only color either 1, 6 or 7 in the next step, right? This was the main thing. Now using this thing, how we can win? If we are able to think, if you are not able to think, I'll just share you that how we are actually going to do it. Actually, to increase our result and to decrease the red's result, what we can do is we can just color, that is, we can color 3 is neighbor only. For example, if I colored this 7, if 3 if opponent has colored 3, and if I color this 7, then the path, that is, one of these paths has been ended for 3. This means that now 3 can color to which nodes? 3 can only color to this 1 or this 6. 3 cannot come to this point, right? So with this, one path for 3 has been managed or has been blocked, therefore 3 cannot color there. Now using this thing, how I can win? I can do what? I can actually find the maximum count. What we can do actually, I have to just color, I'll just color its neighbor, but before coloring the neighbors, I have to keep one thing in mind, that coloring its neighbor will reduce one path for 3, but that path has to be the maximum path, so that if I color that path, I am going to get the maximum number of nodes, right? So what I am saying is, first what I'll do, I'll just count the number of nodes in left child of the 3, number of nodes in the right child of the 3. That is, we are going to maintain a left count and right count, and then we are going to find a number of count of the total tree excluding this 3 and its family. Okay, that means we are going to find the total number of count of its parent, that is of 1, and out of these 3 we are going to choose the maximum. And we are going to color it. So what we are going to do actually, we are going to find the left count of 3, right count of 3, that is going to be 6, sorry, not 6, that is going to be what, 1, and this is going to be 3, right? Why we are actually doing this? Let's see why we are actually finding the left count and right count. Let's say if I color this node, then maximum number of nodes I can color are 1. If I color this node 7, then the maximum number of nodes I can color are 1, 2 and 3. So from here I can only color 3 nodes. Now if I color this 1, then how many nodes I can color? 1, 2, 3, 4, 5, and this including 1 including, that is going to be 6. So I can color 6 nodes. So obviously I have to choose this maximum one, so that I can win the game, right? So here I am going to do what? I am going to find the, let's say x is given, I am going to find its left count, I am going to find its right count, and I am going to find the total number of count after excluding these two values, that is number of nodes in parent, that is obviously 3's parent is going to be 1. So number of node excluding parent, or number of nodes in parent excluding this x, we have to find this. That is going to be what? That is going to be total number of nodes in the whole tree that are given to us, minus the left count plus the right count plus 1. Why this plus 1? This plus 1 is of this node, that is the first initial node that is going to be colored by the opponent. All right, so this is one thing. And after getting this, we have to actually check that if the left count is greater, that is if the left child of the x, that is the first node colored by opponent, are greater, or right child are the greater, or the parent is greater, and out of these 3 we are going to color. Why we are checking for left child and right child? Because there might be possibility that there might be this node, some node, here also 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 some node, and here also node. And let's say there is this another node. So how many nodes are there? 1, 2, 3, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, right? So there are total odd number of nodes. And now if I make if I make a color to, let's say if I color this 7, then I am going to get the maximum number of nodes from where? I'm going to get the maximum number of nodes from this point, right? So I have to check for that. I have to check the right count and the left count, or from here, because we are checking the right count of this 3. So with this, we will be able to find the maximum number of nodes that we can color. Okay, and after this, what we have to check? We have to just check that if the number of colors, let's say I colored, let's say there is no tree like this, it is just this much, and from this point it is getting 6, we are getting 6 as answer, and from here 3 and 1. So let's say if I color the 6 number of nodes, that is my color, I'll say my is equals to 6, then can I win? Yes, I can win. How can I win? I can just see that my color is greater than, I have to check that if my color is greater than the opponent's color. So what is my color? My color is 6, and opponent's color is going to be what? 1 plus 3, 4, and plus this one node that opponent initially has colored, that is going to be what? 5. So yeah, 5 is greater than, so if 5 is smaller than 6, so we won this game. We can also check that, obviously, as we have seen that there are only odd number of nodes, then it is the highest possibility that, or it is going to be possibility that the winner will be having one node more colored than the opponent or the loser's color. So we can check that if my color is greater than n by 2 or not. We can see that here n is 11, so 11 by 2 is going to be 5. In integer value it's going to be 5, so 6 is greater than 5. So with this we are getting the correct answer, that we have won the, and we have to just return true or false. So I hope the explanation was clear to you all. Now let's code this question, and let's with that you will get a more insight to this question. Okay, now in this for this question we are given two functions that we have to complete, and we have also been provided with some global variables that are LC and RC. These are nothing but left count and right count. We have to actually find these things, and we are going to use them further in our program. So first, let's say what we are going to do. First, we are going to use this function, and we'll be calling this, or we'll be getting this right count and left count here. Now what we are going to do, we are going to count the number of nodes. That is, we are going to use this function to count node, and this function we will be completing on our own. What this function is actually going to give us, it is going to give us the left count and the right count of a particular node. If I send any node to that function, or to this function, it is going to give me the left count of that node and the right count of that node. Okay, so here what we are going to pass, initially we are going to pass root and our x. So what we actually want to find, we are actually determined to find the total number of, let's say we are actually determined to find, if this x is passed, we want to find the total number of count to this left side and to its right side. Okay, so with this we have passed this count node. Now what actually this count node, what will the inner body of this count node is going to do? First, the base case is going to be really simple. If root is equal to null, then we have to return what? We have to return we have to return 0, which means that total number of count is 0 currently. Now what we are going to do, we are going to store the left count in, let's say, left, and what that count is going to be, that is going to be something like this, that we are going to call to its left child with value x. Now we are going to call its right child with some value, count node with root dot right comma x. So this two are going to contain the total number of count from left side and from right side. And what we are going to return, we are going to return sorry, left plus right plus 1. Why this plus 1? That plus 1 is going to be of this particular node. Alright, we have to find the right child of this and left child of this, and while we are returning total count. Okay, So with this, but this is not complete. Now we have to use this left count and right count. How we are going to use them? We are actually going to update them. So what this left count and right count is going to be meaning, till here, till this return statement and till these two, what actually is going to be what actually is going to be our answer? Our answer is going to be the count of this whole tree, right? Using only these three lines. But now I want a left count and right count of just this particular node. So what I am actually going to do, I am going to just find the, if somehow I reach to this node, then I have to just store the left count in some variable and the right count. I don't want to store its own data, that is, I don't want to store this one. So for that, I just use this global variables and I am going to update them. Sorry. So how I am going to update them? If I somehow reach to that, point where the value of that root is equal to x, then I have to just update my left count with left and right count with right. Okay, so this is done. So with this is going to be updated, and this will be storing only the values that is going to be in the left subtree and in the right subtree, that is the number of nodes in left subtree and number of nodes in right subtree, excluding this one, that is excluding this root node. Now what we are going to do here, now with this we found what? We found total number of nodes in left, total number of nodes in right. Now we are going to create a variable. That variable is nothing but this variable, number of nodes, exclude number of nodes in parent excluding x, excluding this x. So that is going to be number of nodes in parent excluding x is going to be what? Is going to be total number of nodes minus, as we have written here, total number of nodes minus what? Left count plus right count plus 1. So left count, so I'll write left count plus right count plus this one. All right, now this is done. Now our answer is going to be stored at max count. Let's say our answer is going to be stored in max count. So that is going to be a maximum value of these three. Which three values? That is left count, right count, and this number of nodes present in parent after excluding x. So that is going to be max count of, sorry, not max count, but number of nodes parent excluding x, comma, max of what? Left count, comma, right count. This is going to be so this is going to store the maximum value out of these three. Now our answer is going to be something like this: if my max count is greater than, as we have discussed, n by 2. Why n by 2? Because there are odd number of nodes. So obviously one player is going to color one extra node than the opponent player. So if this is true, then return true, right? This means, this return true means that we have won the game, and if not, just return false. So with this, our program is completed. So currently I cannot show you, or I cannot run this program as our compiler is not having test cases, but soon they will be uploaded to our sites, and after that you will be able to compile and compile this problem, and you can see that how actually this program is going to give us output. It has actually give us just true and false values. So you can expect that just by till then you reach to this video, the test cases will be uploaded to our sites hopefully. So thank you for this video. This is going to be the code part, and as I hope that the explanation part was clear to you all. Actually, what we are going to do, what we are actually doing in here, we are doing nothing but we are actually finding the left count, that is the neighbors count, all the neighbors count, excluding this x, and just we are choosing the neighbor, or choosing that path where we can have the maximum amount, maximum number of nodes, right?